Hi everybody, and welcome to another video brought to you by PLCGurus.NET. So this is going to be another installment in our Studio 5000 Essentials video series that hopefully you've been following along with. And what I wanted to cover today is how we can go about creating, importing, and using Studio 5000 add-on instructions, or AOIs for short. So there is a few things I'd like you to do before we get going here, because there is quite a bit of setup involved. One is I want you to register over at PLCGurus.net. So please head over to https://PLCGurus.net. And the reason I want you to do that is I have just recently posted a step-by-step tutorial that's going to walk you through everything you need to know in order to get to the point where we're going to get to here in this video, okay? And also, at the end of that article, I'm providing you with a link where you can go and actually download the complete AOI that we're going to be working with here today, so that you can easily just import it into your own project and start using it. Okay, so I'm going to include both links to the register and one to the download file, the L5X file that you can go ahead and download. Once you've done those things, head on back and we'll get started. Hi and welcome back. Okay, so I assume now at this point that you've gone ahead and registered over at PLCGurus.net. You've walked through the Studio 5000 add-on instructions tutorial, and you've navigated to the link I've provided so that you could go ahead and download, if you haven't already created it yourself, the L5X file that I have created, which is a packaged component that will allow us, that basically grabs all of the logic, parameters, local tags, everything, allows us to import it into our application. Okay, so again, if you have not done those things, please go ahead and do those things, okay? All right, so assuming you have, let's go over to File, and I'm going to go to Import Component, and the first item here is add-on instructions, so that's what we want to import. And you want to navigate to wherever you've saved the L5X file that I've provided for you completely free. So I'm going to go ahead and just select it and click Open. And it's going to read in that package, and it's going to say, do you want to do this? We're going to say OK, and away it's going to go. It's going to perform the import and actually add it into our add-on instruction tree over in the controller organizer window here. You can see now that we have an AOI underscore cylinder instruction. Okay, perfect. So again, I'm assuming that you've gone through step by step and read through all the parameters. Well, actually, let's just look at them quickly. Please, I'm going to go rather quickly through this part just because, like I said, I assume you are following all these steps. And you can see I want you to acquaint yourself with all the different parameter tags that we've created. Okay, and the parameter tags are the tags that are going to appear in our actual instruction. Okay, so again, we can control whether they appear or not. But you'll notice a lot of the usage. Pay particular attention to this usage column here. Okay. So you can see here, we've defined usages for each one of these tags. So for instance, advanced fault is an output, clear fault is an input. You can just go through the list. And then the oddballs here are these locals, okay? So local tags, they're not an input or an output. They're not going to be accessible to the user program. They are basically internal tags that we are using inside of our logic to control this instruction, okay? So you'll see them down here. Okay, so let's take a quick look at the logic while we're here. And again, please refer back to the tutorial for more details. But you can see I've broken it down into three sections: commands, status bits, and fault logic. So the command logic is basically how we intend to control the outputs, okay? So, we have some, an input command advance, that's a parameter. We're just going to make it a momentary. It's going to seal in as long as all of the permissives are made. We're going to go ahead and seal in that advanced output advanced tag, and we have a retract. So remember, this is a cylinder that is going to perform, it's a standard cylinder with 2 solenoids and advanced return proximity switches, okay? So it's just a basic double solenoid advanced retract type cylinder that we're representing or defining with this instruction. Okay, let's go back to that logic. And then you can see I've created some status bits here, okay? So I'm going to say that we're going to indicate that the cylinder is moving if either one of the advanced or retract outputs are on. Okay, that makes sense. And then of course we're going to set a flag that it is advanced if the advanced input is on and the retract is not. And similarly with the retracted, we're going to say the cylinder is retracted if the retract input is on, the advanced is not. Okay? All right, so moving down to the fault logic. So you'll notice that we have created a parameter where the user can input a time in milliseconds. Okay? So what we're going to do with that is we're going to go ahead and move that time, and you could create 2 times if you wanted to have different advanced retract fault timers, that's fine. But we're going to go ahead and move that time preset into our local fault timer advanced and fault timer retracted presets respectively. Okay? And then we're going to create some simple fault logic to monitor the motion of this cylinder. So we're going to say if the output is advanced and the input advanced is not on within a certain period of time that the user program will define, we're going to say we have an advanced fault. Okay, straightforward. And similarly with the output retract, if the output retract output is on and we don't see the input retracted proximity switch within the predefined user-defined time, we are going to go ahead and set that we have a retracted fault. Okay? And then I just have a kind of an internal flag here. Well, it's not internal, it's actually visible outside as well. To say, okay, if we have an advanced or retract fault, there is a fault present. And if you scroll back up here, you'll notice that that's one of the permissives here. So basically, if I have an advanced or retracted fault, I'm going to de-energize the outputs. Okay? So pretty standard stuff here as far as fault logic goes. So let's get back down there. And then I have a clear fault input that the user program will define a tag for, and then that will drive the clear fault, which will clear or unlatch our fault bits here. Okay? So I hope that makes sense. And again, if I'm moving too quick, please read through the tutorial at PLCGurus.NET. The link is below in the comment section, and get caught up. Okay? Okay, so let's head on over to our main routine here, and I want to draw your attention now to the instruction palette toolbar here. Okay, so right beside the favorites tab, there is something called add-on. Okay, and notice now we have an add-on instruction in our list. Okay, and this happens to be the AOI cylinder that we just imported and created. Okay, great. So what you want to do is you want to go ahead and put that on your rung. Okay, so you can see it's on my rung now. And what you want to do, or what we're going to do, is we're going to start to define all of these parameters. Okay, so I want you just to spend a minute to align yourselves with the parameters you see in the instruction with the parameters we created here in the AOI itself, okay? And here are all the outputs or status flags that we are going to have on our instruction, okay? So there's our status advanced. When the cylinder is advanced, that'll be high. Status retract, status is moving, or if we have an advanced retract fault. And these bits are all accessible now to our user logic in our user program. Okay, so I know this is more of an advanced kind of topic, and I hope I hope it doesn't seem that way, because really it's the implementation and getting in the mindset on how do I make things generic enough, or or identifying what are those things that I find I am duplicating logic all of the time. Right? I mean, any automation project will have multiple cylinders on it. So a cylinder is an ideal candidate for something like this, because what an AOI in effect does is it allows us to encapsulate code And we can actually lock down that code for intellectual property and make it, source protected. And so you want to look for those items or devices or algorithms that you are duplicating many times. Those are ideal candidates for AOI. Okay, and a cylinder is a perfect one. You could have 30 cylinders on a machine. So like I said, this is a standard cylinder, advanced retract. You could have another AOI that has maybe a single solenoid. You could have another one that's a 3-position. It goes on and on. So you could have all of these different AOIs, and then it just is a definition, or it represents a cylinder in the field. Okay, I hope that makes sense. So while we're doing that, what we need to do now is the first tag in the list here, the AOI cylinder. So this is where we have to give it a tag name. So I'm going to right click on the question mark, just like anything else. And notice the data type is AOI underscore cylinder, logically. Okay, so I'm going to go ahead and call this cylinders. And because most automation systems will have more than one cylinder, it may make sense to create this as an array. And let me show you why. So I can go ahead and I'm going to change the data type slightly. And I'm going to go to the dim field here. And I'm going to make it, 32. So what am I doing here? Well, I'm defining cylinders as a data type AOI cylinder of length 32. So now this tag can now accommodate 32 cylinders on my machine, and I can give it an instruction. This is a two solenoid 2-position cylinder. I don't know, something. All right. And now what I would do for the first one is I could just reference it with 0. Because I got to give it an array index now because we created it as an array. Okay. All right. So it actually, okay. So that looks kind of ugly. So I'm actually going to go back in here because what it's doing is it's actually using the AOI description in there as well. So we don't really need this. Let's just get rid of that. There we go. There. Didn't want to say it twice. Okay. So let's go and start populating our fields here. So what I want to do is the first one here is the time underscore milliseconds. So again, this relates back to the fault time, the fault timers here. So whatever value I put in my AOI here is the value that's going to get written to my fault timer presets. Okay, I hope that's clear. And remember, each instruction you add is a separate instance. Okay, so I don't know how, if you have the programming background, but software guys will really understand what I'm saying when I talk about generics, instances, methods and classes, all those things. Okay, if you're not, that's fine. Just follow along and it'll be fine. Okay, so time in milliseconds, I don't know. Let's put in a time of 5 seconds. Okay, so 5,000. That's why we put here milliseconds. We want them to enter it in milliseconds. Okay, so the command advance and retract. So because I'm running an emulator, I want to keep this as simple as possible. I'm actually just going to use discrete toggles here on my simulated I/O modules. You could have predefined or control logic that are going to drive these things, and you probably will. All right, but for now, let's just make it, if I want to advance a cylinder, I'm going to use a push button to advance it. I want to retract, I'm going to use a push button to retract it. All right, so let's go ahead and just start picking off some bits. And data, remember we got to use array 1. And I don't know, let's make it the first one. Perfect. So my push button for advance is going to be the first toggle here. Now to retract the cylinder, let's go ahead and make it the next one. And 1, and we'll make it 1. And now we're going to simulate some proximity switches on our cylinder. So let's make the advanced input procs. Let's say that is wired into, we use 0, so let's use 10. Okay, so 1, 0 is going to be the advanced switch on our cylinder. And we'll use 11 for the retract switch on our cylinder. Oops. Getting click happy here. 11. Now the output advanced. So this is actually the outputs we're using to drive the valve, okay? So let's go ahead, which in effect drives the cylinder, all right? I hope that's, that connection is there for you. So I'm gonna go 0, and let's go ahead and make that 0. Okay, and we'll make the retract 1, so everything kind of lines up nicely. And just navigating through here, and we'll go 1. And then the circuit fault, or the clear fault, or the fault reset button, I don't know. Let's just pick a tag that we can toggle. 13 is an unlucky number. Let's use 13. I always look for those little goofy things. I don't know. Anyways, okay. So we've effectively created everything that we're going to need to be able to play with some switches, look at the logic, and get going with this, okay? So the next step is now to, of course, save it. So I'm going to go ahead and file save as, and let's go ahead and save it. Well, there's one there, AOI. Let's save that. Yes. Okay, so the next thing we want to do is now download our project into the emulated processor. And of course, if your path is there, you're all good to go. If not, be sure to traverse RSWho, which is you can think of RSWho as a window into your RSLinx configurations. Again, if you're not sure, go back to some previous videos, and we're just going to go ahead and click download there. And download yes. And controller and run mode, yes we do. And there we have it. Okay. So now is where we're going to have to use our imagination a little bit here, because I'm going to be going through and clicking and switching some switches on and off. So let's just recap one more time what we did here. So our command to advance, you can think of these two as push buttons, okay? Or some other logic that you're going to have to drive these things to turn these advanced retract outputs on, okay? So that's going to be 0 and 1. And the proximity switches are what we're going to use to simulate that the cylinder is advanced or retracted is going to be 10 and 11. And then the outputs to drive the valve that drives the cylinder is going to be output 0 for advance and 1 for retract. And then of course the fault reset or circuit reset is going to be 13. Okay, so let's go ahead and just command the cylinder to advance. So you can see my output 0 is on and my status is moving. But I'm not going to do anything. Let's get a fault. Okay, so perfect. We've seen an advanced fault. So this is nice to do too, because it gives the user who's ever troubleshooting this system some nice visuals to see what is going on. Okay, so I want to show you something. I'm going to right click on this and I'm going to open up instruction logic. So this will give me a read-only view in real time of what's happening. So you can see here the timer preset is now 5 seconds because that's what we defined in the instruction. Okay, let's go back there. Oops. Okay, how did I get back there? Oh, let's just go here again. I got too many things open, I guess. Okay, and you can see here, because my advanced input did not turn on, I have latched a fault, advanced fault, which is correct. And because I've latched a fault, that turns my fault present bit on and drops out both outputs. So I can't do anything now. Whether I try, the outputs are not going to turn on because I have an existing fault, a persistent fault in my instruction. And that's by design. We want that. Okay, so let's go back to the main routine. And let's go ahead and toggle the circuit reset. And that clears the fault. Okay, so let's do that again. So let's go ahead and this time let it be successful. So I'm driving it. As long as I can turn that on in 10 seconds, bang. My status is advanced now. Did you see that? Let's go the other way. I can toggle this off, right? My status is advanced. So now imagine my cylinder is advanced. So I'm going to go ahead and toggle the retract input now. And we need to turn that one off. My output is on, and I want to turn that on. And look, we successfully retracted it. Okay, we have to be quick. We only have 5 seconds, remember? All right, so let's turn that, take that back. We'll turn that off, turn that on, and we'll toggle that off, and we're advanced again. I know it's not ideal. We don't have real hardware and things in here, but if you play with it, you'll get a feel for it, okay? So let's take a look now at what happens when, oops, let's turn that back on. what happens when I try to do both? What's going on here? Let's go into our logic again. I just want to see if that works. So I'm going to go into instruction logic. And notice if I try to do both, it de-energizes both. So that's what we want. So that was the whole purpose of this. So it's a little protection in place so that if the user code tries to enable, by accidentally, by mistake, whatever, tries to enable both outputs at the same time, we're going to say, no way, man. You can't advance and retract at the same time. And that's what this guy here is doing and this guy here is doing. They're interlocked with each other so that only one output can be enabled at any given time. Okay, so let's go ahead and advance. And there's the advanced procs is on. Away we go. And let's try the retract. And let's get a fault on the retract. Let's actually go look at this. So you can see it's timing and it faulted because I didn't toggle the retracted input on. Okay, so I hope this is driving home the use of AOIs a little bit. I know it's not ideal. We're just flipping bits around, but I hope it's clear what we're doing. Okay, so and again, if you had multiple cylinders now, if you had another cylinder, all you would have to do now is, add another instruction. We're just going to drag this down, and this is going to be cylinder 1, and away you go. You populate your fields, all your logic plugs in, and you're done. Okay, so I hope this drives home the use of AOIs. I hope you found this video informative. And again, if you haven't already done so, which in this video I hope you have, please check out our community at https://PLCGurus.NET. Become an active member in our community. And thank you for watching. Thank you.